two swan and a cygnet eating the weed. That's the noise you can hear. Having their dinner. I was thinking about chirality and direction, and I thought, hey, I know, I can be like a real physicist. So this is what real physicists do. They say things like, well, something moving backwards in time can't possibly collide with something moving forwards in time. That's obvious. So, what if there was a ring carrying positrons and electrons in opposite directions? Now, what do I mean by opposite directions? Well, I just mean the positron and the electron are going in the same direction, but one's going backwards in time, of course. So I've invented the spin singlet state. And now, when you spin that torus around, you put a twist in it somehow. There are all sorts of ways of doing that. So you spin the torus from one side to the other, you put a twist in it, and then at some point you cause something to happen which splits the positron off one side and the electron off the other, and they go flying off with opposite spins. And then in order to know which one you've got to bring them back together again. You've got to keep the system as it only works as a whole, so you've got to bring them back together again. And only then do you know whether you've got the one that was the inversion, or the other one. So you cook something up like that, and you say you've solved the EPR paradox, and then you write it up in a paper, and you put enough of those equations in and a few homotopy proofs, and you talk about how the homotopy hypothesis, it works because the infinity groupoids are a probability space. And you say, oh, they're a Haar measure or something, and you do some calcs and do some really impressive equations, and then you launch your career. And I'm sure you'll find dozens of things you can apply it to. Like bridge design. That's quite cool, isn't it? It looks better on camera than it does when you have the whole field of view. That was a really cool day, Janet. Thank you.